Welcome back to the Scotti-BYTE channel, and this is Scott. So this is going to be one of those times when I talk about two completely different subjects and try to relate them. And I have my little assistant in the background there, Bam Bam, is paying attention to me right now. Not, you know how cats can be. So anyway, I'm looking at a new application that came out just a few days ago called HomeLabable. And so it's either HomeLabLE or HomeLabable or HomeLab something or other. Anyway, it is basically an application that allows you to detect systems or servers on your network, and then you can draw a diagram showing the representation between them and even monitor those systems. And it's in its infancy right now, so I really expect it to become something later on. But you notice that I have here HomeLabable and I say -Incus external storage. And one of the reasons for that is because, although not completely related, I'm going to kind of leverage HomeLabable in order to show a very common technique that's used in home labs in infrastructure data storage. And that is external storage with Incus. So in the past, I've shown Incus storage in regards to Incus volumes in the storage pool and mapping data in that way. But this time, I'm going to do things just a little bit different. So here what we have on the left-hand side of the diagram is we have a Docker container. And that Docker container is going to be nested inside of an Incus container, which I do very frequently. But this Docker container also has persistent volume data. In this particular case, it's in /app/data. And that's going to be mapped to a folder out on the Incus container itself in /home/scott/HomeLabable. And then that's going to be in turn stored up on the Incus host, because it's going to be mapped from the Incus container out to the Incus host on which the Incus container is running on. And then in turn, that's going to be NFS mounted on a remote server such as a NAS device. So here real quickly, this is the HomeLabable application. And we basically install it with a Docker build command. It says that HomeLabable is a self-hosted infrastructure visualization solution, and it provides a network scanning feature to accelerate the identification of machines and services deployed on your local infrastructure. And it has some screenshots here showing you how you can manage the program and how you can manage the topology diagrams that the program creates. And here's an example of a HomeLabable diagram, and you can move things around on the diagram, and you can change connections between things, and you can create other entries here. And it also has the ability to scan the network and find entries on your live network, and then you have the ability to add them in here to the list of devices. And so it's doing a scan right now on the 192.168.1 network, which isn't a subnet on my particular home lab. But if there were things on that network, it would find them and list them, and then I could simply drag and drop them onto this diagram and add them as part of the infrastructure. This is simply a sample that they generate after you load the program. So with that in mind, let's go see how to install and configure HomeLabable. Here we are logged into my Demo 1 Incus server, and right now I don't have any Incus containers, so if I do an Incus list, we're not going to see anything listed out. I'm going to create an Incus container, and I'm not going to go into everything that we're doing here other than to say that we're creating this with the default profile and the bridge profile, which grants it an address out of my main LAN as covered in the Incus step-by-step tutorial that I frequently mention on the channel. And also we have boot.autostart equals to true, which means that when the Incus server starts, it also starts this particular container. And then we have security.nesting equals to true. And the reason for that is because we're nesting an Docker container inside of an Incus container. Okay, so the next step after having created and started our container is we're going to do an Incus shell into HomeLabable. So now we are inside of that new Incus container. Anytime you create a new container, or for that matter, anytime you install a new operating system, it's always a good thing to take all of the updates. So I'm doing an apt update, & apt upgrade -y, so we're not prompted on whether or not we want to do that. I've not included the sudo command because when we Incus shell inside of the system, we are root by default, which means we have privileges. So here we're doing that update, and we're going to see if there's any upgrades that it needs to take. And it looks like everything is completely updated. So the next step we want to do is we want to install some dependencies. And the dependencies for this particular application is going to be the OpenSSH server, so I can SSH into this to maintain it, the Nano text editor, net-tools to be able to do commands like ifconfig, the curl command, the git command, and CA certificates. So now we're going to go ahead and install all of those, and as soon as that's done, we'll be right back. Now that all the dependencies have completed installation, the next thing we're going to install is Docker from the script on the Docker website, and we do that with the curl command. And once that's done, we'll be back here again. Now that Docker's installed, I'm going to go ahead and create myself a user account with an add user, Scott. I'm going to give Scott a password, verify that password, and then I'm going to go ahead and do a usermod-a, capital G, sudo, comma, Docker, and then the username Scott. And what that does, it puts Scott in the sudo group and also puts Scott into the Docker group. Now I'm going to do an su space dash space Scott, which goes ahead and signs on to the Scott account, and we can begin our installation. Now we're going to go ahead and create a folder in my home directory, and so tilde means start at the home directory, /HomeLabable /data. The -p says create any part of this structure that doesn't currently exist, and then we cd into the HomeLabable folder. Now we're going to go ahead and make a copy of this project because it's not a matter of just running a simple container. We actually have to build the container via a Docker build command. So here I'm doing a git clone, and the git clone command goes up to GitHub and makes a copy of that project here locally. And then through some magic here, I'm going to go ahead and copy those files here. And after I get done copying them, I am going to remove the original installation temporary directory. And after I've done that, I'm going to go ahead and remove all the YML files that were actually a part of the project. And you might wonder why I'm doing that. And that's because I have a YML project, or actually a compose.yml, that simplifies this. And the next thing I want to do is I want to copy over the .env folder, or env file, which is the environment variables file, which is something that you normally find with Docker applications. Since I deleted all the YML files, I'm going to do a nano on compose.yml. I didn't have to name it Docker Compose, simply any file with .yml will be processed. And then I'm going to paste in the contents of the Docker Compose file that I've been working here on tweaking. So the HomeLabable application really has three containers. The first container you see up here is the backend container. The second container you see down here is the MCP container, and the last container, and the one that we're going to be most concerned with, is going to be the front end container, because that's the container that we're going to communicate with. If we scroll up to the top here and look at this, you'll notice that this thing has one volume. And really the secondary, or almost the primary subject of this video, is going to be talking about how we take persistent data and store it in other places external to Docker and external to Incus, and even out on another server on our network. So here I have the volume /home/Scott/HomeLabable/data, and it's going to /app/data. And so that's the complete pathway of this particular backend. And of course, the backend is going to be the database and the controls to access the database. Something else you want to take note of is you'll notice here that this backend is not simply accessing a container from the Docker Hub, but instead it is doing a Docker build command here, and it is building the back end, and it does that with a Docker file. And then as we scroll down further, the other thing to take note of is that the front end is accessed via port 3005. And I'll have all the details on what to change here in the show notes, but once you've completed making the changes to the file, you're going to go ahead and do a Control-O and Enter to write the file out, and a Control-X to exit the Nano editor. At this point in time, since I said that we're not simply going to pull the containers, but we're going to build the containers, the command we want to use is docker compose up-d to make it detached, which you're familiar with, but then we want to do a --build, and that --build command will actually go out to a file called Docker file with a capital D, and it will look at all the directives in that file and build the container manually as opposed to downloading the container. After a few short minutes, if everything worked as expected, you should have where it says that the three containers were built and that the network was started, and then the three containers are started. And to kind of verify that, you can do a docker compose logs. If you can spell it, docker compose logs. And if we look at that, you'll see that there are no errors there, and we don't see anything particularly spectacular. So the other thing you can do, of course, is you can do a docker ps, and what you're looking for here is that the application is up and running healthy. And so that's what we see here, and we know that things should be good at this point. So now if I do an if config, we have several network devices from the various Docker containers, but we're looking for device ETH0 here, and it's running at 172.16.2.23. So I can go ahead and make a copy of that address, and I'll run up here to my Chrome browser and I'll paste that in. And remember, it was going to be offered at port 3005. And so I hit port 3005, and here we have the HomeLabable application. It's going to start by default with the username admin and the password admin. And then you can click sign in, and at this point you're going to have the standard template example that they have here. So I could go out and move these things around, reconfigure them, and I can even go over and hit the delete key and delete things, and that's what I'm doing here. I'm deleting everything, and so therefore everything is pretty much gone now. So we have a blank canvas. What exactly do you do with this application? Well, we can say scan network, and earlier I told you what my network, or I didn't tell you what my network address range was, but I could pick, say, 192.168. Let's say 80. Let's try 80.0/24, and what that is one of my subnets out here. And so it'll do a scan of that subnet, and right now it says that there's 0 devices found. And so for a while I thought that these scans weren't really working correctly, and I went back and I was looking at the scan history, and of course it says 0 were found here in the 176.16. But if you go down here, you can see that I did have a few networks I entered, namely 172.16.1.124 found 70 devices, and 192.168.80.0/24 found 33 devices, which is one of my VLANs. So this just is a scan history. But if you go up here to pending devices, then you can see the list of devices that are pending here. So it can call out what it believes it's found, and it will try to tell you a little bit about what that device is and what kind of service it's offering. And it won't always name it exactly correctly, but we can try it out here. So for example, 80.20 here, we'll just go ahead and bring this thing over here by double clicking it. Click it once, I guess, and say, okay, do you want this thing? And this is host web home, which happens to be my web server. And I'll go ahead and say, yeah, go ahead and approve that. And it says, all right, what exactly is that? Is it a NAS? What is it exactly? So I'm just going to say it's a server. And you can give it different icons that you can select down here. I haven't played with that a whole lot. And you can come down here and then I think we're going to have to shrink the screen down a little bit smaller so we can see the save option. Yeah, we do. And I can go ahead and save it. So there's web home. And web home is a web server, as I said. So I can go down here in the list, and here is another server at 192.168.80.210. And that's a host name called Tools. I can go ahead and approve that. It tells the services that it's running. I'll just go ahead and again, I could pick an icon. I'll just go ahead and say save that out. Here's Tools down here. I could draw a line between these, trying to show some type of connectivity. I could say whether it's Ethernet, Wi-Fi, VLAN, whatever. So the whole idea here is you understand your infrastructure. This thing doesn't build it automatically. It will discover the nodes out there and the services it has on the nodes, but it's kind of up to you to build the topology that has on your network. So I'm really looking forward to what this is going to do in the future, because I think it's really going to be a powerful tool. I like tools that can let you draw a topology that's kind of a WYSIWYG, as opposed to something like maybe NetalertX that's more tabular in nature. So when this was new, I just thought I really needed to take a look at this. So here's the thing, I digress, because this really wasn't about the HomeLabable application, it was about data storage. So if I do an ls here, this thing downloaded the pieces of its application. There's the Docker file for the back end. There's the Docker file for the front end. We have some documentation. There's the compose YML file we built. Something else you should be aware of is if I do a nano on the .env file that we did further earlier, the program doesn't yet have any way to set a username and a password in it, but you can go in this .env file before you ever build it, and you can go ahead and set the admin, and it gives you the command that you can use here to generate a new hash, with a Python command in order to hash a password, and therefore you put the hash in here, and then you can have your own password on the account. So you can set that up. You can also, if you like, hard code your scanner ranges in here, or you can do that from the GUI. So those are all kind of capabilities. But what I wanted to show you is you'll recall the data folder. So remember that we had a non-volatile mapping for the data folder. So it's persistent data. So there we go. If we cd into data and we do an ls, there we have HomeLabDB and scanconfig.json. So that's the data that's in here. So that data is part of this Incus container, but it's really inside of the Docker container. But remember, everything in Docker is volatile, which means that if we shut down the Docker container, the data goes away unless we've mapped a persistent volume. And again, we mapped a persistent volume. So if I go to nano on compose.yml, if I got that right, let's see, what was that? Compose.yml. Oh yeah, right, cd ... And then nano compose.yml, we go down here and there's our volume. And so we have that persistent data that's stored in there. So when we shut down our container, we still have the data folder. So what if we wanted that data folder not to be stored inside the Incus container? What if we wanted that data folder to be accessible out on the Incus server instead of just in the folder? And the reason we might want to do that is we might want that data to be backed up elsewhere or accessible by other applications. So while we're still inside of the container, I want to do an ID command. And Scott inside the container has a user ID of 1001 and a group ID of 1001. If we exit out of here back to the Incus server demo 1 and we do an ID, the user Scott out here has a UID of 1000 and a group ID of 1000. So notice they're not the same from inside and outside the container. So therefore, I want to create a file mapping so that they will kind of be the same. And I'm going to do that here with the printf command. And I'm going to go ahead and set what's called an ID raw mapping. Now that I've accomplished that on that particular container, then my next step is going to be to make sure that I have created a folder in order to map the data to. So in this particular case, I previously had created a HomeLabelle folder here. And now what I'm going to do is I'm going to complete the mapping for that data inside the container to outside the container with the command incus config device add HomeLabelle, and that's the name of the container. And I'm calling this thing an arbitrary name of HomeLabelle-data, and then it's considered to be a disk. And then the source is home Scott HomeLabelle, and that is the folder path that is on the Incus server that we're logged into right now. But then the path is the path inside the container, which is a little bit different. It's /home/Scott/HomeLabelle/data. So we do that, and it says data HomeLabelle-data added to HomeLabelle. And now if I do a cd to HomeLabelle and I do an ls, we don't appear to have any data in that right now. And so this is the embarrassing part where I sort of missed a step. So I'm going to do a cd ... to kind of come up here at this level. And there's a couple of commands that I probably need to do. So one of them is I'm going to go ahead and add this definition for the 1000 group here to the root capability. And then I'm going to do the same thing for the GID as well. And now that I've done those, in addition to the printf command that you saw earlier, where I do the mapping from 1000 to 1001, we now have the user mapping, but then we have the privilege to actually use the mapping. So at this point, if I do an ls and I cd into HomeLabLE and I do an ls, you also see no data, which was not expected at all. Okay, so let's see if we do an Incus restart on HomeLabLE, and it says it's already stopped. Yes, that's right. I forgot the container wasn't started, so it always helps if it's started. If we do a start on the container, now we are going to have the mapping we were looking for, and we do an ls, and as expected, we have no data again. All right, so this is really great. I can't figure out what's going on here. So why don't we restart Incus just for fun? Sudo systemctl restart Incus. And then we'll go ahead and say, why don't we restart our container again? And then after that's done, we should be in great shape. So we do an ls, and now there is the HomeLab database as we expected to see. So now we should be able to go up there and do an SU over to Scott. Well, actually, let's do a little bit of a test. Let's go ahead and do a touch on Scott.txt, and that'll go ahead and put a file in here. And then let's go ahead and do an Incus shell over to HomeLabLE, and then let's do an SU over to Scott. And let's do a CDN to HomeLabLE. And let's do an ls. Let's go into data and do an ls. And there we have our Scott.txt that you saw. And likewise, to test it in the reverse direction, we're going to go ahead and do a touch on Scott2.txt. We do an ls, there it is. We created it from the container side. Now we're going to exit and exit again. And here we are in that folder, but on the Incus container, or on the Incus server rather. And now we can do an ls, and there we have both files. And likewise, we should be able to do a remove of Scott*.txt, and it will remove both files. And the database, of course, is still here for the HomeLabable folder itself. And the purpose of this was to be able to map that database back to the Incus server, which we have achieved. You're going to want to take a look at the show notes for today's presentation to get all the details behind this for sure. And so here we are back on the demo-1 Incus server, and we have this HomeLabLE folder. So now we have the Docker container storing its persistent data in a folder called data, and then we have that being mapped back to the Incus server in a folder called HomeLabLE that we just looked at. And now the final step for this is we want to go ahead and NFS mount that folder back to a NAS that I have. So we're going to do a sudo nano on /etc/fs tab, which is the file systems table. So normally we never mount things inside of Incus containers, and the reason for that is because we don't really have kernel access to mount block-oriented devices. So that was why we mapped the data from the Incus container back to the Incus server host. And now, as an example, we have here this mount command for NFS. This is the address of the NAS that I'm going to. This is the name of the NFS export, which is the terminology that we use for an NFS share. It's similar to a Microsoft share, except that it's network file services in Linux. And then it's going to be pointed to a mount point on /home/Scott/HomeLabable on this Incus server. It's of type NFS. I'm choosing NFS version 3. NFS version 4 is the latest. I found NFS version 3 to be a little bit more resilient. And then I've got a couple of interesting options here. And those are no fail and also underbar netdev, which makes network mounts a little bit more resilient and tolerant to devices going offline. So having done that, I do a Control-O and Enter to write the file out, and a Control-X to exit the nano editor. The reason why we put the NFS mount command into the FS tab as opposed to just doing a mount command was because when we reboot the system, we want that file system to mount automatically. That being said, to test this, we could reboot the system, this Incus server demo 1, to see whether or not the file system mounts, but there's an easier command, and it's sudo mount-a, meaning mount all devices of T, means type NFS. So what that will do is it will go out and look at those things and perform that mount accordingly. And there it said it created a symlink for the target file system. If I type a mount and hit enter and look down here, you can see it is in fact mounted. So how do we know that that actually worked? Well, one of the things that I can do is I can go up to my NAS system, VMS Cloud, and I can go ahead and refresh this folder. And when I refresh the folder, you can see here that the HomeLab database is clearly not being shown, which is not what I expected. So let me go ahead and go out of it and come back in, and it should be there, but it is not. So it's a good question. Why is this not there? If we head back down to the demo 1 server here and we do an ls command, the fact that we see HomeLabelle in inverse video means that it is in fact mounted. So if I do a cd to HomeLabelle, we know that earlier the data was being moved into here and we could see it appropriately, but now we're not able to see our data for whatever reason. And so this is the point at which I realized that order definitely does matter. So we'll do an Incus restart on HomeLabelle, and that'll go ahead and restart our container. So if you remember, the last thing that we did was the NFS mount. If I do an ls, you still notice that HomeLabelle is in reverse video. But now when I cd into HomeLabelle, since the NFS mount existed before the container was restarted. Now when I do an ls, I should be able to see the database, and sure enough, I do. And conversely, if I go back up to my NAS here, you notice that the HomeLab LE NFS export shows HomeLab database as well. So again, the order certainly matters. On the surface, this application might have appeared to be a little bit disjointed, but in reality, we really were talking about two things that do have a relation to one another. So as a way to sum this up, HomeLabable is a new self-hosted infrastructure visualization solution. It's only been around for a couple of weeks, and I really look forward to the capabilities that this program will have in the future. And so HomeLabable can scan and find your network instances, and then you can create visual flowcharts of your systems in order to monitor them, or more importantly, to self-document them so you can determine when there are problems, where is everything, and how is it configured. So the key message in this tutorial was really to show how Docker application data can be mapped to external storage. And we probably could have used just about any Docker application to do that, and HomeLabable was a fairly simple one because it really only had one Docker persistent storage volume, and so that allowed us to look at this a little bit more simply. In reality, it probably wouldn't be the use case you would choose, because storing the data for HomeLabable inside of its container, its Incus container, would have been the simplest thing to do. But sometimes an application has large storage requirements, or sometimes you want that data backed up elsewhere for other reasons. So we looked at Docker persistent storage first of all. HomeLabable has a persistent volume, and so that was storing it in a folder in the Incus container. Secondly, we looked at how to take that Incus container storage and map it back to the Incus server on which that container was running. And finally, we took that Incus server folder and we mapped it to an external NFS share on something like a NAS device. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit your notification bell, and we'll see you next time.